got you. Wherever you want it from, we got what you need. Total online class, we got you.
Good day, everyone. Once again, you are welcome to Toydel online class. Just as I've introduced the set of numbers. So the first set of numbers. Good day, viewers all over the world. You are welcome to Toydel online class. Today we want to look at higher derivatives. Higher derivatives. That is, if y is a function of x, then the y, the x, which is same thing as f prime, is same thing as f prime. That is called the first derivative. That is when we take the differentiation of y with respect to x, the y dx is same thing as f prime, the first derivative. We can go ahead and find the second derivative. That is, we can have the square y all over the x squared. This will be same thing as f prime prime of x. This is referred to as the second derivative. We can also go ahead and find the next derivative as the cube y all over the x cube. This same thing as f prime 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 of x. This is referred to as the third derivative. We can actually continue up to the nth derivative. That is, we can continue from there up to where we have the ny all over the xn, which is same thing as f nth derivative of x. So this is referred to as the nth derivative. So when we talk about higher derivatives, it has no bound, it has no end. It depends on the nature of the question. We can actually we can keep differentiating up to infinity. So let's just note that this is called the nth derivative. It's called the nth derivative of y with respect to x. So please, let's note. So we've been talking about 6 or 7 videos that we have done. We have been talking about the y ds. But what we are trying to say here is that we can have more than the y ds. We can have the second derivative. We can take the third derivative, fourth, fifth, and in that order. So it is possible. There's possibility to have more than one derivative, and that is what we are trying to explain here. So I'm going to take about 2 or 3 examples so that we'll know how to differentiate when it is more than first derivative. Example. Let's take example. Example. Say, find the cube y all over the x cube, given that y is equal to sine s squared. So let's look at this. This is sine s squared. It's not sine s squared all squared, though. It's sine s squared. So what do we do here? For us to be able to find the derivative of this, we are looking for the third derivative. So y is given as what? Sine s squared. So I won't be able to find this sine function of this s squared. So I will represent this s squared as u. I can say let u equal to s squared, so that du dx will be equal to 2x. Then once we have gotten the u dx, then y will be equal to what? Sine u. So dy du will be equal to cos u. Then from here, we know that dy dx will be equal to du dx multiplied by dy du. Du dx is given as 2x multiplied by cos u, and that simply means that we are going to have 2x cos u is given as s squared cos s squared. So the first derivative, dy dx, is what we have on the board. So that's the first derivative. Then in this first derivative now, y is given as sine s squared. When we take the derivative of with the differentiation of sine s squared, we were able to get 2x cos s squared. So this first derivative now has a product of both exponential function and trigonometric function. So how do we differentiate if we want to do the second one? So we go ahead and take the second derivative. Look at We have gotten the value of dy dx as what? 2x cos s square. So how do we take the second derivative? So for us to be able to take the second derivative, we are going to apply product rule because this is the product of polynomial and trigonometric functions. Then the square y all over the s squared will now be, if I don't want to waste time, when I pick this first one, I will differentiate this. I will differentiate this. I'll come and pick this. I will differentiate this. So if I pick 2x as u, this is u, this is u, and this is v. Product formula, u dv dx plus v du dx. So in this case now, when I pick u, 2x squared, multiply by dv dx, if v is equal to cos s squared, of course, I will represent this as something. When I take the derivative of this, I'm going to get 2x. Then what's the, no, this can be equal to cos u. What is the, when I have cos u, that will be minus sign. So if I take, what I'm trying to say is that this v, this is v is given as this. What is dv dx? Let me solve dv dx here neatly. If v is equal to cos s square, then I can represent s square. Let me say, I will say v, let v equal to cos g. Then that simply means that g is equal to s squared. dg dx is going to give me 2s. That's what I'm going to get. Then dv dg is going to give me minus sine g, because when we differentiate cos, we get negative sign. At the end of the day, dv dx that we are looking for will be dv dg multiplied by dg dx. Then what is dv dg is minus sine g multiplied by dg dx, 2x. At the end of the day, we are going to have minus 2x sine g is given as s squared. That's what we are going to get. That is what we are going to get. So we can actually do this straight away, but I just want to show you to us. So in this case now, we have, using this formula, u, this is u, dv dx is given as, into bracket, minus 2x sine s squared, then plus v cos s squared. That is v. V is cos s squared. So if v is cos s squared, then multiply by du dx. This is u. U is 2x. Du dx is 2. That is what you are going to get. At the end of the day, the second derivative will now be, if we do that, we are going to get minus 4s squared sine s2 s squared plus 2 cos s squared. That's what we are going to get as the second derivative. But in that question, we are asked to find the third derivative, the cube y all over the s cube. So from here now, we go ahead and take the third derivative. That is, we now say the cube y all over the s cube. So in this case now, this is the product of two functions, this is the product of two functions. So I can do this directly, having in mind the formula for product rule. So when I pick this, I differentiate this. If I pick this, I come back and differentiate this. And that is what we are going to do. That is what is expected. So if we do that, what do we get? So if I pick this first one, I will differentiate this. I will now come back and pick this, I will differentiate this. So let's see what you're going to get. If I pick this, minus 4s squared multiplied by, what is sine s squared? Sine s squared is what we are given from the onset. When we take the derivative, it's given as 2x cos 2x. So this is 2x cos s squared. That's what you're going to get. So I've picked this first one. I've gone ahead to differentiate the second one. Plus, I will not pick this second one. I will differentiate this first one. Plus sine s squared multiplied by, what's the derivative of this? This will be minus 8s squared. That's what we are going to get. So I'm through with the first part of the square y over the s squared. Plus, we now come to here. If I pick this first one, if I pick 2, multiply by, I will differentiate cos s squared. So what is cos s squared? If I differentiate cos s squared, I'm going to get, if I differentiate cos s squared, I'm going to get minus 2x sine s squared. Then plus, when I pick this, I differentiate this. If I now pick this, I differentiate this. Of course, when I differentiate, constant is 0. So this will be plus 0. So we can go ahead and write everything neatly. This time, this is going to give me minus 8s cubed cos s squared cos s squared plus plus times minus, that will be minus 8s squared sine s squared minus 4x sine s squared. That's what you are going to get. That's what we are going to get. So do we have something that is common? Do we have anything that is common? Nothing is common. Nothing is common. So here, how do I get this? We pick this, you differentiate. We now pick this. Well, if I pick this minus 8, not minus 8 s squared. So here it's minus 8. This is minus 8. This place is minus 8. Okay, that's what I'm going to get. Then at the end of the day, I'm going to get minus 8s cubed cos s squared minus 8 minus 4. I'm going to get minus 12x sine s squared. So this is what we are going to get as a final answer. So we cannot proceed from here. So the cube y all over the s cube is given as what we have on the board. So we take another example. Let's take another example. So let's take another example. Example 2. Let's take another example. Example 2. Example 2, where we have given that y is equal to ex minus e minus x. Show that the cube y all over the s cube plus the square y all over the s squared plus dy dx plus y is equal to 4ex. This is what we are given. So invariably, we are asked to find the first derivative, second, and third. We are given y. Y is given as what? Ex minus ex. So dy dx, the first derivative. Of course, the differentiation of ex is ex. So check my video on derivative of exponential functions. You know this. Then this is minus. And of course, minus, when we take the derivative of this, this is here is the coefficient of x here is 1. The coefficient of x here is minus 1. So if I differentiate minus s, I'm going to get minus 1. That will be minus 1. That will be minus ex minus e minus x. That's what I'm going to get. At the end of the day, I will have ex minus times minus is plus e minus x. That's what we are going to get as the first derivative. Then we go ahead and take the second derivative, the s squared. So we want to differentiate this. If we differentiate this, what do we get? I'm going to get ex when I differentiate this first one, no problem. But by the time I will differentiate the second one, I'm going to get plus minus e minus x. Then at the end of the day, I'm going to have it to be ex minus e minus x. So we now go ahead and differentiate the third time, the cube y all over the s cube. So if you do that from here, I'm going to have e raised by x minus in the bracket minus e minus x. The minus is plus, so I'm going to have e x plus e minus x, and that's what you're going to get. So the question says that we should show that if we add the cube y all over the s cube plus the square y all over the s squared plus the y dx plus y, I'm going to get 4x. So now let's substitute for this value. What is the cube? From the question now, the cube y all over the s cube is, we have been able to get it to be x minus a plus e raised by minus x. Then the square y all over the s squared is plus ex minus e minus x. The y dx is given as plus ex plus e minus x. Then y is given as ex minus e minus x, and that's what we are going to get. So if we now simplify, let's simplify this further. This is e raised by minus x plus e raised by minus s minus e to minus, we cancel out. This is plus e raised by minus s minus e raised by minus x, we cancel out. At the end of the day, we are left with 1, 2, 3, 4. We are left with 4 e raised by x. And that is what we are asked to show. And we have been able to show that. So we have been able to show that. So we take one more example. Then We'll close for the day. So the last example in this class, example 3. So the question says that if y is equal to x plus square root of a squared plus s squared, where a is a constant, where is a constant, we have to prove that a squared plus s squared the square y all over the x squared plus x dy dx minus y equal to 0. That's what we are asked to show. So of course we know what to do now. We are given y. We go ahead and find dy dx. We also find the square y all over the x squared. So the first question is what we are given is y is equal to x plus square root of a squared plus s squared. That's what we are given. That is what we are given. So from there, we are going to find the value of dy dx, the first derivative and the second derivative. This is what we are given. And of course, this is the same thing as you saying x plus a squared plus s squared, everything raised per half, because square root is the same thing as raised per half. This is why. So what is dy dx? Dy dx will be the derivative of x. When I differentiate x, I'm going to get 1 plus, if I want to differentiate this now, I'm going to apply function of a function. And what do we do under function of function? Differentiate the core. Here is a constant, so derivative the differentiation of a constant is 0, so here will be 0. Then here I'm going to have 2x as the core, multiply by this power will come down, 1 all over 2 into bracket a squared plus s squared. You subtract 1 from the power, minus half. So please, for you to be able to differentiate this other part of the question of y, go and check my video on function of a function. You have an idea of what I've done. This will cancel this. And at the end of the day, I'm going to get 1. I'll get 1 plus x into bracket a squared plus s squared into bracket minus half. That's what I'm going to get. So if I do that correctly, this is what I'm going to get. So that is that about that. Then I'll go ahead and look for the second derivative, the s squared. So if I want to differentiate this the second time, then this is what I'll get. If I differentiate constant, is 0. So I don't have any problem here. So I now have product of two things. I have product of two things. So in this case now, I have product of two things. If I pick this first one, I will differentiate this second one. Then I'll come back and pick this, I will differentiate this. So if I pick this now, the first one, x, multiply by, I'm going to differentiate this other one. Then what's the derivative of this? What I have inside is 2x multiply by minus half will come down into bracket a squared plus s squared minus half minus 1 minus 3 over 2 plus, I'll pick this. When I differentiate this, this is going to give me 1. If I pick differentiation of x is 1, so I'm going to get a squared plus s squared into bracket minus half. That is what I'm going to get. That's what I'm going to get there. Then this will take care of this at the end of the day. So we are going to get the square y all over the s squared to be equal to minus s squared into bracket a squared plus s squared minus 3 all over 2 plus a squared plus s squared minus half. That is the value of dy dx. Please, for you to have proper understanding about this, you check my video on function of a function. So we have gotten the value of y. We are given the value of y. We have gotten the value of dy dx, and we have gotten the value of the square y all over the s squared. So we go ahead. So let me write the value of dy dx here. dy dx is given as 1 plus x into bracket a squared plus s squared raised by half. So now let's go ahead and show what we are asked to show. So we are asked to show that a squared plus s squared, the square y all over the s squared plus x dy dx minus y. We want to show that is equal to 0. That's what we want to show. We want to show that is equal to 0. So how do we show that? That's what we are about to do now. So we have a squared plus s squared into bracket the square y. I'm going to substitute for the value of the square y, that's minus s squared a squared plus s squared raised power minus 3 over 2, then plus a squared plus s squared raised power minus half. That is what I have there. That is the value of the s squared, then plus x into this value of the y, x into bracket 1 plus x into bracket a squared plus s squared, everything raised power minus half. That's what I'm going to get. Then minus y, y is given as x plus a squared plus s squared, everything raised by half. That's what we want to show, that this is equal to 0. That's what we want to show, that everything there is equal to 0. So I can open up here. This is a squared plus s squared. If I use it to multiply this, I'm going to get minus s squared minus 3. When I use law of indices here, minus 3 over 2 plus 1. That will be a squared plus s squared, everything raised by minus half. That's what I'm going to get. If I do that correctly, that is what I'm going to get. Then plus, if I use this to multiply this is raised by 1 half. I'm going to get a squared plus s squared, everything, that's 1 minus half, that is half. Plus, if I do this, I'm going to get x. X times x will be plus s squared into bracket a squared plus s squared, everything raised by minus half. Then minus x minus a squared plus s squared, everything raised by half. So if we look at this very well, we realize that minus s squared, a squared plus s squared raised by minus half, we cancel this. This is minus and this is plus. A squared plus s squared, everything raised by half, minus a squared plus s squared, this we cancel out. And at the end of the day, s minus s, we are going to everything, we have gotten the value of everything to be equal to 0. And that is what we are required to do. And that's what we have done. So I would love to stop the class because of our time. If you have any question under derivative of higher derivatives, just type at the comment section. I promise to check the comment section and provide solution to any of your questions. Thank you and God bless you all.